Another common class of security vulnerabilities on Android applications are known as hardcoding issues. With hardcoding issues, they're mostly the act of hardcoding information into our source code that is potentially exposing information about how the application runs, or maybe exposing something like a username or password or some sort of sensitive data. So we're going to take a look at two types of hard coding issues in this video. The first one is sort of the classic hard coding issue where we've hard coded a password into some Java file. And since we compile it, we figure no one is going to be able to decompile it and be able to get to that password. However, that's not the case, as we can see through decompiling. And then the other one will be a little bit more complex, which will involve actually shared libraries and shared objects and discussing how we can potentially extract passwords from those as well. So you'll see in this, we need to enter in some sort of vendor key in order to access this section. So if we try to access it, we'll say access denied if we enter the wrong values. So in order to extract the password for this, we need to find first the activity that corresponds to this login page. And in this case, it would be hardcode activity. Now, a lot of the times it might not be named exactly like this. It might not be as easy to find the activity. If you need to try to find this as well, you can also take a look at the log messages or the displayed messages in the alerts. So as you can see, this one has that same access denied message, so we know that we're probably in the right place. Now, looking at this code, we can see that we're taking a look at the HC key text field. We're getting the text and we're checking if the string equals vendor secret key. So as you can see, we've hard-coded in the password, and this means that it's very easy for someone to decompile this application and figure out the password for this. So now from here, we can just type in vendor secret key and press access, and as you can see, access granted in this case. So this is one type of very common hard-coded activity problem where we hard-code a password in plain text rather than doing something like obscuring it or encrypting it or hashing it or putting it on a server or something like that. There's a whole lot of different things that we could be doing that aren't this. Primarily, we would be wanting to potentially hash the password in order to protect it. But even then, someone could get the hashed password and try to brute force it with an offline attack. So that's not really the best way to do it. Typically, what we'd want to do here is sort of verify it on server side or place it somewhere that someone wouldn't be able to access it if they decompile our application. So that'd be the key idea. So let's go ahead and discuss the other type of hard coding issue. And this one is relatively similar. Again, we have to enter in a password. If we get the wrong password, it will give us the access denied message. And if we enter in the correct password, it will say access granted. When we look at the hard-coded activity, which is hardcode 2 activity, you'll see that things are slightly different here. You see it's grabbing djni.access. So this is a method from the djni object, which is this one here. So what we want to do is we want to find this class to determine what the access method is actually doing. So if I go into this class here, which I have here, diva.jni, you'll see that there's a static load that happens. So it's loading a shared library, and the SO name is diva.jni. So as we discussed, we can find shared objects under resources, under library, and you'll see that it's compiled for every different type of processor, but each of these shared objects are going to be the same, the main difference being the assembly language that it's targeting. So really any of these are going to be able to give us information. So these shared object libraries, as we discussed, they can't really be decompiled in the traditional sort of way. We can't go from a shared object to source code. However, what we can do is we can search these shared objects for strings. So what I mean by this is that any sort of static text, we're able to extract from these shared object libraries. There's a number of different ways to do it. I like to use a utility called strings. And what strings does is it essentially allows us to search the whole library for these static strings. So you can see here, I've grabbed a copy of the library. If you want to grab a copy of the library, what you can do is you can change this APK to a zip folder. And then once you do this, you can open up the zip, and then you can go into the libraries folder like before, and then extract the value from there. So that would be the way that you would be able to extract it if you're looking to extract it onto your device. And then utilizing strings, we're able to search it for any sort of text that may exist. So let's go ahead and open up command line. I'm going to go ahead and cd to this directory. And then the way that it works is we just go strings.exe, and then we type in the name of the file that we want to search. So it would be the libdiva.jni.so. And you can see here we get all the text strings that are existing inside of that .so file. Now, from here, we have to do a little bit of thinking to be able to extract out the ones that are important to us. You'll notice all these dot ones here. If you have some familiarity with assembly languages, you'll know that these dots will typically correspond to labels or points to jump to. So these dots, like text files text data, they aren't really as important to us because they're just like sort of like divisions of the file itself. So we aren't really interested in those. We can see that these GNU and GCC are probably telling us what this was compiled with. So this information, again, isn't necessarily relevant or interesting. The gold 1.1 looks to me like a version number of something. And we can see here GNU :version. So this is probably just a version number. So that's not necessarily important. You can see these are other shared objects that are being used. So again, these aren't really particularly important. These again are mostly labels. So it's indicating the end, the BSS start, the E data. So those aren't really something that's going to be interesting. Similar with these here for the same reasons. strcopy is a C function that's likely being used inside of here. These appear to be just like information about the actual library itself, which will leave us with these three pieces of information as well as this. So when we're taking a look at these, we sort of want to extract which ones are relevant to us. So from these, we can sort of essentially just trial and error them to see which one is the correct input. There are some other ways that we can sort of like look at these and be able to decode information from them. Usually when they have like the $sign character inside of them, it means that there's some sort of scripting thing related to them. Potentially it could be like an argument in a bash script or something like that. A lot of the time these will correspond to like code lines, for instance, which means that this is probably the only one that's just general text. So if we think that this one is the right one, then we can bring it over here and try to input it in and see what will happen. So OLSDFGAD semicolon LH. When we try to access, you'll see that we get access granted. So obviously this is the proper password for it. So you can see from here that even though we can't necessarily decompile the shared objects, we can still search them for the strings that exist in them. And if we have a hard-coded string inside of there, we're going to be able to extract that string and potentially leak information such as the password. So this video gives you a bit of an idea behind how hard-coded text is able to be utilized to potentially expose data about Android applications. So these sort of vulnerabilities do happen every so often, and a lot of the times the shared object ones are maybe a bit more common because people are a bit less careful when they think that the thing can't be decompiled. But also if they obscure the files at all, if we can sort of like manage to unobscure the code or unencrypt the code, we can potentially figure out these passwords. So not only are plain text information necessarily a bad idea, but also even just like putting hashes into the code could be dangerous because then you can do like password-based attacks to try to decrypt them. So this gives you a general idea of the sort of things that you can look out for these types of vulnerabilities. So now you can take a look for these in any applications.